Okay, so we're going to do a quick demonstration of this more geometric property of the gradient before we do a question about it. So I went ahead and I drew a picture that should look kind of familiar to y'all from when we were learning about level curves, when we first started thinking about functions of three variables. So here is a graph in 3 space of the function z equal to 10 minus x squared minus y squared. It's going to look like an upside down bowl that has height 10 in the z direction. And then I've drawn in like blue the level curves I took at different slices. And then I drew the level curves down here in the xy plane. So when z is down at 0, a vertical slice is a circle with radius 10. Square root 10, sorry. And then up here, I made a mark on this point because we're going to talk about it at x equals 2, y equals 0. So I'm right here on the x-axis. You're going to get z is 6. 10 minus 2 squared is 10 minus 4. Z is 6. So that's on the level curve z equal to 6. And so that right here is a circle in the xy plane with radius 2. And then up here, maybe I drew a level curve at z equal to 9, and then there the radius of the circle should be much smaller. You'll end up with one with radius 1. Okay, so that should be kind of review for you. And then we're going to talk about grad f for z equal to f of xy, f equal to 10 minus x squared minus y squared. So we just learned how to calculate this, so we could go ahead and do that. Grad f is going to be minus 2x minus 2y, just from taking partial derivatives of f with respect to x first and then with respect to y. But I just told you the special feature of gradients, which is at any point on your surface, grad f is a function of x and y, so you could go to any xy coordinate you want and calculate it. But the xy coordinate on the surface here maybe being 2, 0, when I plug that in, it should give me the direction to head for the steepest descent. So if you're right here on the surface and you want to start increasing z as much as possible, hopefully it makes sense to you that you'd kind of head straight up like that. If you kind of went side to side, you can imagine that you'd be making a spiral around the surface, not going up it as quickly as if you just went, too many arrows over here, right up this way, kind of climbing up the bowl instead of around the bowl. And then if we calculate grad f at that point, 2, 0, I've got minus 2 times 2, comma, minus 2 times 0. Oops, maybe more deliberate here. So that's minus 4, 0. So that's telling me that if I'm at this point, I should be heading in the minus x direction and not at all in the y direction if I want to move up the bowl quickly, which is exactly what we just said. We said don't move side to side, just go up in the direction you came from, and then you'll be okay. And the reason I drew these level curves is because what the gradient is going to be is actually in the xy plane. Oops. And it's actually always going to point, it'll be perpendicular to the level curves towards the next highest level curve. So this thing we said before, that it points in the direction of steepest descent, is still true. But another way to visualize it is with these level curves. So plotted in the xy plane, grad f at every point is normal to the level curve and points towards the next highest curve. That's saying the same thing as the direction of steepest descent. Sort of the fastest way to move to another curve is going to be heading straight off your curve, not going side to side. And then in order to be ascending and not descending, it'll be heading towards a higher level curve. So hopefully that kind of helps make more of a connection than this paragraph about what the gradient is. One of those things, either words or pictures might connect with you. So now we're going to do that quick example, I promised. So if f of xy is equal to x e to the 2y minus x, in what direction is f increasing most quickly at the point 2, 1? And then even more than that, what's the maximum rate of increase? So when we're asked a question about increasing most quickly or even decreasing most quickly, because that's just the opposite question, we're going to immediately think of gradients. So I saw increasing most quickly, and I knew that I had to go ahead and compute a gradient. So this one's going to take some chain rules, it looks like. So I'm actually going to go ahead and do this the careful way because I'm worried I'll make a mistake. And if I show what I'm thinking, then that won't hurt me very bad. So I'm taking the derivative of f with respect to x. So I'm going to take the derivative of x as 1 times the other function plus keep x the same and take the derivative of this. So that's minus 1 from that x power e to the 2y minus x. So this is just going to be e to the 2y minus x all times 1 minus x, just factoring out this common e. I'll do it like this. And then my minus x came from there. And then df dy, I actually don't have to worry about the chain rule on, so x is unaffected. And then a 2 comes out front from the power on the y, and then e to the 2y minus x keeps the same argument. So that's 2x e to the 2y minus x, writing it a bit more neatly. And so my grad f at every point is given by e to the 2y minus x times 1 minus x. You need to end that parentheses. And 2x e to the 2y minus x. And then I want to know what direction f is increasing at the point 2, 1. So I have to evaluate my gradient at the point 2, 1. So that's going to be e to the 2 times 1 minus 2, e to the 0 times 1 minus 2. 2 times 2, e to the 2 times 1 minus 2 is again e to the 0. E to the 0 is 1, so this is going to simplify to minus 1, comma 4. And that's the direction of steepest descent, or the direction f is increasing most quickly. That's just like this little arrow I drew, but for the new surface we're thinking about. And then the maximum rate of increase, when we first introduced this idea, I told you would just be given by the magnitude of the gradient. And so rate of increase is just the magnitude at that point. So that's going to be the magnitude of minus 1, 4. So that's the square root of minus 1 squared plus 4 squared. That's square root 1 plus 16, so square root 17. And so that's going to be the maximum rate of increase. And so this first thing showed us kind of how to think about this property. And this is how we would actually use it to learn stuff about the function f of xy that's given to us.